Today's lesson is in your notes packet on pages 6 and 7. We're talking about lesson 3.3, solving two-step equations. This is where things are going to get a little bit more complicated, even though you can still mentally do a lot of these equations. I'm going to ask again that you are writing down all the steps and showing your work, because otherwise it's not going to end well ultimately when we kind of keep moving through this chapter here. So what we are working to do with solving two-step equations is we are still continuing to isolate the variable, just like when we had one-step equations, and we are still going to continue to use those inverse operations. Things get a little bit more complicated here because we're going to see multiplication or division and addition and subtraction in here. So one of the things that I'll direct your attention to down on the bottom of page number 6 here is this little phone that's down here that says solving equations, don't call me after midnight. So our equations are going to get more and more complicated, and they're going to include distributing, combining like terms, moving variables. We're not there yet. So for today, if you want to cross those off, that would be good. What we're going to focus on today is undoing addition and subtraction first, and then undoing multiplication or division second afterward. So going back up to the top of page number 6, example 1, I'm going to have you drop a line down your equal sign. And again, we still have this variable. And remember, variables are letters. Letters are loners. They like to be alone. So we're trying to get this G all by itself. And first, you're undoing addition or subtraction. And I see a plus 11 right here in my equation. So I'm going to go ahead and do a minus 11. That's the inverse operation. And draw that line across so you can kind of reduce and simplify your equation now. This 4 is still stuck to the G, so when I come down here, I do need to include 4G still, and 23 minus 11 is going to give me 12. 4 and G are stuck together by multiplication. Your inverse operation for multiplication is division. We are going to show that with the bar. We're not going to put a little division symbol anymore. We're 7th graders, and we're going to show this with the bar. So we're going to divide by 4 and divide by 4. So we get G equals 12 divided by 4 is 3. What that tells me is if I were to actually plug in 4 times 3 plus 11, I should get 23. Following order of operations, 4 times 3 is 12 plus 11 equals 23, and 12 plus 11 does in fact equal 23. So I did this one correctly. That's how you would go back and you could check your work. I will not require written out checks like that, but if you get something that doesn't seem right, go back and just plug it back into the original and see what ends up happening. Example number 2, drop your line down your equal sign. Again, here's my variable. It has a 3 attached to it. Addition and subtraction first. So I'm going to undo this subtraction with addition, inverse operations, bring down that 3b, bring down my equal sign. 35 plus 10 is 45. 3 and b are put together with multiplication. I'm going to undo with division. Whatever I do to one side, I'm doing to the other side. 3 divided by 3 really gives me 1, and 1b really just means b. So I have b equals 45 divided by 3 is 15. Take a look at example number 3. This one's not complicated other than the fact that the equal sign is on the other side. So we're still going to follow the same steps. We're going to get this A, and we're going to try and undo addition and subtraction first. So I'm going to have you solve this one, undo addition and subtraction, then undo multiplication and division. You're going to type your answer in as A equals, and then whatever number you get. So add 7 to both sides undoes the subtraction. 5 plus 7 is 12. Equal sign. My 4a comes down because these are canceled now. 4 times a, so I'm going to divide by 4, cancels. A equals 3. So in your answer, you would have written in a equals 3. Example 4, this is what I call like a rule buster one. It's kind of a weird one. We're going to do a couple more examples of this. There's the variable, and I have this 13 that's hanging out front here. Anytime there's no symbol in front of it, it's automatically assumed to be a positive. So how do I move a positive 13? What's the inverse of that? It would be a negative 13. Do it to one side, do it to the other side. Cancels. Be careful though, because see how this 3 has the negative in front of it? So we're going to bring down negative 3d Over here we have -8 and -13, which gives us -21. Multiplication is happening here, so I need to divide by exactly what's attached to the d, so that way I actually get them to cancel out. Divide by -3. So d equals, and that ends up a +7. Example 5 is one that has division in it, and I know that because I see this fraction bar and it involves my variable. So I'm going to deal with this 28 first. Again, just like the last example, there's nothing in front of it, so it's going to be a positive. So I'm going to subtract the 28 from both sides. I'm going to bring down b over 26 equals 30 minus 28 is 2. To undo the division, because it's b divided by 26, I'm going to multiply by 26. This is actually using the inverse property, because what you have when you have b over 26 is you have 1 over 26 times b. So you're multiplying by the inverse, which is 26 over 1, so that these actually cancel out to give you that 1. So that's still using that inverse property again. This side, we're also going to multiply by 26, so b equals 52. In example number 6, we have 1/4 times n, and we have the -3, so I'm going to take care of the -3. Draw my line across because I'm going to simplify. 25 plus 3 is 28, equals 1/4 n. We are using the inverse property here. We're trying to make this 1n, so we're going to multiply by 4 over 1, which is really just 4. So on this side, I'm just going to write it out as 4. That allows those to cancel. And 28 times 4 is going to give me 112. I'm going to have you go ahead and try example number 7 then. Drop your line down. Look back at example 6 to see what we did with that fraction that was attached to our variable. So I'm first going to add 5 to both sides. We'll bring down the 2/3 x, and this is going to be equal to 12. Fraction times here, we're multiplying by the reciprocal. Multiplying by the reciprocal. X equals 12 divided by 2 is 6, and 6 times 3 is 18. Our final example here, this is a little different, but if you remember this phone that was right here, remember the first step was to distribute? So we could actually distribute this -12 out. -12k minus 48 equals 60. This looks now like a regular two-step. So we're going to add 48, inverse cancels, -12k equals 108. -12 is stuck to the k with multiplication, so I'm going to divide by a -12. Divide by a -12, so k is equal to a -9 here. On the next page, these are what I call some of my rule busters. So we actually saw one on the last page, which is what we're seeing here in example 9. So this 6 is positive, if you remember. I'm going to have you go ahead and solve example 9. So you would subtract the 6 from both sides. That'll leave you with 3x equals 9. That's canceled. 3 is attached with multiplication, so I'm going to divide by 3. Those cancel. X equals 3. Go ahead, take a look at example number 10. I'm going to have you solve this one as well. So we're going to subtract 7 on both sides. Those will cancel. I have -10x, -23, and a -7 is a -30. I'm going to divide by a -10, and I'm going to get x equals 3 as my final answer then. Example 11 and 12 look a little crazy here, but we're going to go ahead and do these. So I have a situation where I have a division problem, but I also have addition. But if you remember from order of operations, we would have to approach this first. And when we're actually solving equations, we're doing order of operations backwards. So we don't want to touch this top junk, as I'm going to call it, until the very, very end. Okay? So we have is what I'm going to call that, divided by 5. So I first need to undo divide by 5. Undo divide by 5 by multiplying by 5. Multiplying by 5. That'll cancel those out. All we have left here is the x plus 2. So we're going to bring that down. And 7 times 5 is 35. We're going to subtract 2 from both sides because, again, we're still trying to get the letter by itself, and we're going to get x equals 33. In example number 12, drop your line down. Put the top part in parentheses. We have blah divided by 5. So we're going to undo divide by 5 with a times by 5. Do it on both sides. Those will cancel. Bring down the blah, and you can let go of the parentheses now, and 5 times 7 is 35. Go ahead, take it from here, and I'm going to have you solve the rest of this equation now that it's just a basic 2-step. You're going to subtract 11 from both sides. This will give you 24 equals 4x. Divide by 4 on both sides. So x is equal to 6 then. All right, that is it for your 2-step equations lesson. Your next thing is going to be work in your practice packet.